Okay, today what we're going to talk about is solving systems of linear equations using graphing. So what we want to do with this is we want to go ahead. First, there's a couple of things that we need to understand, okay? And so if a system has at least one solution, it's said to be consistent. So what we can say is when we look here and we see two lines that are crossing at one point, that's the solution, the point where the two lines cross, then we call that consistent, okay? So if a consistent system has exactly one solution, and it's also what we call independent. If it has an infinite number of solutions, it's dependent, okay? So that means that basically the two equations have the exact same slope and the exact same y-intercept. And then if the two lines are parallel, or if they will never cross any way whatsoever, and that's pretty much the only way that they would never cross is if they're parallel, we would call that inconsistent. So we can see examples of consistent, dependent, and inconsistent. Okay, so we have a way of solving this here, and this is an example, and you see that we have two equations written here in standard form. Okay. First thing that we want to do is we want to go ahead and put them into slope-intercept form. This example takes it down to where it says y equals 7.48 minus 5.23x. Well, I went ahead and I switched that around to have negative 5.23x plus 7.48. And then our other equation that we were given, it's just showing how it's being solved, and it ends up with y equals negative 2.11 plus 6.42x. Again, I went ahead and I just put that into slope-intercept form. So what we want to do with these is we want to go ahead and enter both of these equations into our graphing calculator. So what I want to do with my y equals on my graphing calculator, if you have anything on there right now, clear it out. And for y equals, what I'm going to do is I'm going to type in the first equation where I have negative 5.23 plus 7.48. I made a mistake. 5.23 x plus 7.48. And then my next equation, I would write 6.42x minus 2.11. And then what I want to do is I want to graph these. And it'll come up on your graphing calculator, maybe. I may have not hit. Let's see here. Oh, here it comes. Okay, fantastic. I was afraid that I made a mistake and it didn't graph the second one. Okay, perfect. So we have our points graphed. Now, if we go back to this page, it says hit second trace. I made a mistake. Can you believe it? And I should have put the number 5. That's what you hit, second trace, hit the number 5, then enter, enter, enter on your graphing calculator. And we'll see if we do this, second trace, number 5, enter, enter, enter. You'll see where the two lines intersect. This gives us the exact coordinates where they intersect. And so you can see here where it says 0.82317597 and 3.1747897. And on your paper, it just goes and it gives you the simplified or the rounded answer of 0.82 and 3.17. That is the exact point, or the approximate point, I should say, where the two lines intersect. So let's go ahead and talk about what that really means. So let's go ahead, go to the next page, and we have negative 4x minus 2 and negative 2x plus 1. First thing I'm going to do is I'm going to go ahead and hand graph these. I want to graph these by hand because it's so much fun. I have down 2 and slope of negative 4. So I would go up 1, 2, 3, 4 and back 1. So that's negative 4 divided by negative 1. Up 1, 2, 3, 4 and back 1. All right, so down 1, 2, 3, 4 over 1. So I would graph this, and I would end up with something like that. Sorry about the crooked line. So then I have negative 2x plus 1. I'm going to go ahead and use a different color. There's my plus 1. Negative 2x. So I go down 2 to the right 1, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And I have another negative slope like that. Now, the problem with this is, and it might be the problem just with what I have here on my board, I'm not exactly sure where these two are specifically intersecting. So what I want to do is I want to go to my graph, or my graphing calculator, I should say, and I'm going to go ahead and I'm going to clear these out. And then what I want to do is I want to go ahead and enter these equations in. So I have negative 4x minus 2, enter, and I have negative 2x plus 1. So now I want to graph. And this is much more, as you can see, a little bit more precise than what we end up when we're graphing on the graph paper. It just turns out that it's that way. But what I want to do with this is I want to hit second, I want to hit trace, it's number 5, enter, enter, enter. And it's telling me that my intersection is negative 1.54. So going back to our paper, I'm going to write in negative 1.5 comma 4. Now what does that mean? What that means is this is a point that satisfies, or that could work in both lines, where both of these lines intersect. And what we can do with that information is we could graph it to see if it actually works. So I'm going to go ahead and substitute in. I'm going to start with negative y equals negative 4x minus 2. I want to go ahead and start with that equation. So I'm going to go ahead and substitute my values in. I have 4 equals negative 4 times negative 1.5 minus 2. So I go ahead and I do my math and I say negative 4 times negative 1.5, and I'll go ahead and I'll get 6. So 4 equals 6 minus 2, and 6 minus 2 is 4, so 4 equals 4. That checks out for that equation. But we're not done yet. We need to check that point for the other equation too, which is negative 2x plus 1. So I'll rewrite the equation again. Y equals negative 2x plus 1. And what I'm going to do is I'm going to put in my values again. 4 equals negative 2 times negative 1.5 plus 1. 4 equals negative 2 times negative 1.5 is 3. plus 1, so 4 equals 4. And again, that checks out. All right. So let's go ahead and look at our next one. I'm going to go ahead and skip this one. I want you to go ahead and do this one on your own, graphing it as well as checking it on your graphing calculator, checking your values, making sure that it works, because I want to move on to number 6. There's an additional step that we have to do here for number 6. And the additional step is we have to solve for y. Okay, so what I'm going to do is I have 3x minus 5y equals negative 30. So I have negative 5y equals negative 3x minus 30. A lot of negatives going on there. So I end up with y equals 3/5 x. Please don't say 0.6 plus 6. All right, there's my first equation. And then my second equation is, and double check my math. I haven't been doing very good on my math today. Maybe it's because it's a Friday. And so my other one is x minus 5y equals negative 20. So negative 5y equals negative x minus 20. So y equals 1/5 x plus 4. I'm hoping those are correct because that's what I'm going to work with. I'm sure you'll correct me if I'm wrong. So for my green line, or for my green equation, I'm going to go up to 1, 2, 3, 4, 5, 6. There's my y-intercept. And now I have a slope of 3/5. So up 1, 2, 3 over 1, 2, 3, 4, 5. And 1, 2, 3 over 1, 2, 3, 4, 5. So I have a positive slope right there. Now I have 1/5 x plus 4, so I go up 1, 2, 3, 4 on my blue equation, 1, 2, 3, 4. And I have a slope of 1/5, up 1 over 5. 1, 2, 3, 4, 5. Come on. Down 1 over 1, 2, 3, 4, 5. And so I have a line like this. Well, it looks like that the line of or the point of intersection, excuse me, is going to be 1, 2, 3, 4, 5, 1, 2, 3. I'm thinking it's negative 5, 3, but what I want to do is I want to check. So I'm going to go to my y equals, maybe. Here we go. And I'm going to clear these guys out. I'm sure you're sitting there going, Miss Askew, there's a better way to do that. And so now what I want to do is I want to go ahead and put in negative, I'm sorry, 3/5 x plus 6. So I have my 3/5 x, so I make my fraction. That's not what I wanted to do. There we go. So we have 3 over 5 x plus 6. Enter. And then our other one is 1/5 x plus 4. And we can graph them. All right, fabulous. So now what we want to go ahead and do is we want to figure out where we're going. So we'll hit second, trace, 5, enter, enter, enter. And we have -5, 3. Perfect. So we have -5, 3, -5, 3. And then what we can do is we can substitute these in. So 3 times -5 minus 5 times 3 equals -30. So this is -15 minus 15. Sure enough, it does equal -30. It checks out. The next one, I have, let's see, -5 minus 5 times 3 equals -20. -5 minus 15, sure enough, does equal -20. So it works out. What I'd like you to do is definitely for finish is to do number 5 on your own. Choose, I want you to do number 7 and choose between, so you have to do 5, 7, and choose between 8 or 9. Thank you.